CMucam. This is a little sensor that you can use to track colors and will make your life easier for this project, at least in this class. And maybe anything else you want to do with microcontrollers that involves vision processing. So for the overview of this talk, I'll be going about the background of the CMucam, a little bit about color tracking in general, and also how to deal with lighting. And then we'll go into the specifics of the board about what's on the board, what are the connections. I'll talk a bit about the graphical user interface I wrote for it and how to use it. And then we'll talk about the Arduino interface library you can use to communicate with the camera, and a few examples of how we can use the camera for this particular class project. So a background about the camera system. The CMucam4 is the fourth version of the series of CMucams. There was the CMucam1, 2, 3 beforehand. This project was started in about 2000, so it's been going on for a while. Now, the CMucam4 is the logical successor to the CMucam1, while the 3 was the logical successor to the CMucam2. The 1 and 4 operate in a different mode than the 3 and the 2, in that the CMucams 1 and 4 do not have a buffer to actually store the image as it comes off the camera. With the CMucam 2 and 3, they had a little buffer that could do that. And so what that means is the CMucam 4 is always doing its image processing literally as the pixels are being generated from the camera. It does its processing and then it throws the pixels away. So it never actually sees more than 160 pixels from the camera at any point in time. The 2 and 3 were able to actually store a large image, and they could do multi-pass processing. The 3 was actually able to do a bit of face tracking because of that feature. This is going to be important for any how the CMucam4 works, and if you have any questions about why some things are implemented certain ways, it's because the 4 doesn't have any buffer. It can't save any of the memory coming off the camera. Anyway, so let's talk about color tracking. There are two color spaces you're going to work with if you use this device. You have RGB mode and YUV mode. So in RGB mode, you can imagine there's a color cube, and there's 3 different axes. The one axis is red, and one axis is green, and one axis is blue. And so they all go different directions. And the act of color tracking, at least for the CMucam4, is you're going to build a box. You're selecting a red, green, and blue, min and max, and you're making a small box inside of that big box. And so the object you want to track is basically its color is bounded within that cube. For YUV mode is a rotation of the RGB color cube. So if you see this central, it's like this point right here, that'd be white, right? And so if you move diagonally through the cube, you'd be at black at the very end. In YUV mode, we rotate that cube such that black's in the bottom and white is pointing upwards. And then you're going to take cross sections from that cube, and those will look like these color planes, essentially. And so in YUV mode, or this is also sometimes called YCRCB mode, or there's other different names, YIQ mode. Those are all just different rotations, so they have slightly different numbers for different values, but they're the same idea in that we've separated the lighting from the actual color. And so this, if you work in YUV mode, you'll have slightly improved tracking from RGB mode. So it's nicer to use if you have to deal with lots of changing lighting conditions. RGB mode, though, is nice to use also if you feel like if we want the images to make sense to use, because in YUV mode, images don't really map correctly to RGB mode. Any questions on that? Sorry, it's kind of confusing, but it's not. It's really a small difference that you'll notice when using the CMucam4 at least. So when you're actually illuminating a scene or such, you in general want to make the light source such that it's, well, the CMucam4, we want to make the CMucam4 such that it's pointing down at an object. This way you can have the best lighting on the object, and the CMucam4 sees the illuminated side. A lot of people will use color tracking sensors and put the camera over here, or put the camera down there. And the problem is the CMucam4 will be seeing basically the shadow of an object. And for color tracking at least, that shadow changes the hue, well, it doesn't change the hue, but it changes the color, the intensity of the blue or red or whatever. For example, these colored balls I have here. it makes them look different. So you in general, if you get the best tracking, you want to have the CMucam4 being above your object looking down, or at least on the same side as the light source. Okay, so now for some more meaty material. Let's get a CMucam out. Okay, so this is a CMucam sensor. This is the SparkFun model. So for the SparkFun model, and there's also a black model we have, which is the Mechatronics model. You can buy both these online and they're in stock. So for this model, I'm going to talk about how we can power it, hook up to it, and what are all the ports and connections to it. Zoom in. Okay, so for this model, okay, let's get the best lighting we can get. There's a bunch of different connections on it. So let's first start with the power. There's multiple ways you can power the thing. It has a DC barrel jack right over here, so you can just plug in any DC voltage source you want to it. The thing actually supports up to 9 volts normally, but it will take 12 volts and even higher if you wish to push it. The thing actually runs internally at 3 volts though, so if you put in a 12 volt source, it's going to start to get warm, and it'll work fine, it won't fail on you or anything, but if you were to insert, let's say, a really, really old SD card at the same time, you may have some current issues. So it's rated at 9 volts such that the thermal power dissipated by this regulator is exceeded. Anyway, there's also another connection over here which you can bring in power if you want for the SparkFun model at least. And then on the bottom here in this 6-pin connector, your Arduino, if you were to put it directly on top of your Arduino, can supply power to it. So there's a VIN connection and also a 5-volt connection which you can do with power. All those connections have a diode going into them, so you don't have to really worry about power being plugged in backwards or something like that. Okay, now this device is actually like a co-processor to your Arduino, so you connect to it via serial interface. And so there's a few different places you can connect the serial interface to it. There's a 6-pin connector here which attaches to one of these FTDI style connectors. This is a cable. You can't really see the end of the cable. There's a USB port in my computer though, and that's attached to this guy. So this is the cable you can buy at SparkFun for 20 bucks. It's an FTDI programmer, so it's useful for programming your Arduino. But also the CMucam4 has the same connection, so you can just plug this guy right in there, and the camera will get power and turn on. And then you can communicate to it with the serial through that. There's also another 4-pin connector here for serial. That's just like an auxiliary connector though. You don't really need to use that. It's for another purpose that if you're working for Arduino, you don't have to worry about. There's also a 2-pin connector here which can be used to communicate with your Arduino. If you're going to put this down on top of your Arduino like a shield, you can use these 2 pins right here and it'll just connect directly to your Arduino. Finally, there's some servo ports up here. So this thing has a built-in pan and tilt servo controller, which are on this connection right over here. So you've got your pan on the first one, then tilt, it's clearly marked on the device. And then these last 2 pins will be the power for the thing. So you have to provide your own power to the servos if you want to use this. The reason why is servos can draw quite a bit of current, so we don't want to actually run them through a 5-volt Arduino. If you feel like doing that though, anyway, there's a small solder jumper you can jump on the bottom of the board, which will connect the servos directly to the Arduino's 5 volts. But it's not recommended since that will cause brownouts and other resetting issues. Also, if you want to, there's a few connections down here, so you can cut the power to the auxiliary and power light on this board. That's so you can reduce the current consumption if you'd like, because you can drop this thing down to about 100 microamps of power consumption for deep sleep or such. Finally, there's 2 connections you can cut over here too with an X-Acto knife, and and those will allow you to disconnect these serial pins from these two pins here, such that you can drop whatever connection you want in your Arduino. You don't have to do that though. This 6-pin connector has everything you need, power, ground, and serial, so you can just route all your connections right to that and connect to the CMucam4. Finally, there's this video output, so you may have noticed this guy was outputting some video beforehand, and that's what's there. Any questions? Connections? Okay. Moving on. Okay, so now we're going to get into the fun stuff. How to actually track colors on this thing. That's what it does. So the CMucam4 is a color tracking sensor. It is not a digital camera. What that means is when it takes pictures, it has to do a lot more work than a regular digital camera to take a picture. So we have no mouse. So it's going to get out. Okay, so this is okay. So on the right here we got the CMucam GUI. It's kind of wrote this over the Christmas break. So what it'll let you do is connect to the CMucam and really debug your application and figure out how you want to track the color or whatnot before you have to connect the thing to your Arduino. So it really helps out figuring out exactly what settings you're going to tell the camera to track the color with and other things. So to use the GUI, you press the begin button first and you select the serial port the camera's connected to. So that'd be serial port 4. And so if it connects to the camera, it's going to reset the camera, so you may have noticed that happen over there. But once it's connected, it'll give you the version number on the bottom and allow you to do some stuff with the camera pretty much. And so now I'm going to send an image to the PC from the camera. And so now it's sending that image. Now, the thing I mentioned before about how this is not a digital camera, the way it actually sends the image, because you can't buffer an entire image, it has to send that image through the serial port at the serial port speed. It can't buffer the image to save it and then send it as leisurely as it likes. So because of that, I have to actually limit the data rate at which I'm sending data through the serial port. This means that the image is being sent in vertical chunks. So you may have noticed all these lines in this image right here. That's because the image is being sent of 480 pixels per frame or sent down the serial port. And the image is composed by over multiple frames. So this is the difference between a regular digital camera, which will save a complete picture, and it has a piece of memory that allows it to save it to the memory real quick, and then it can transmit that to an SD card or put it over to USB or etc. to make the picture look cleaner, or just be able to grab the picture at one time. Because this thing has to send one column at a time through the serial port, that means you can't move whatever you're taking a picture of in the image. A lot of people seem to do that, and you'll get wavy lines and other crazy stuff, so just don't move whatever object you take the picture of. Now, looks like I need to give myself a bit more space so I can see a bit more on this image. Let's try to. Yeah. Any questions?
Yeah, well, you mentioned it's bad at tracking moving things.
No. It's not bad at tracking moving things. It's bad at taking pictures of moving things. There's a slight difference. So it actually runs at 30 FPS internally, and it tracks colors at 30 FPS. The issue is when it's sending an image over the serial port, do you think about the data rate at which we're sending data? Okay. Turn the auto gain back on. No, so think about the data rate at which data is coming from the camera. There's actually a 640 pixel by 480 pixel image coming through at 30 FPS, and there's about 2 bytes per pixel. So when you multiply that all out, you're getting, quite a large number compared to the slow serial port rate of 250 kbaud. So there's literally no way you could ever transmit a complete image through the serial port in any way, shape, or form. That's why I have to just take one column of a frame. Because I don't have a buffer, I can't save the image and then transmit it at my leisure. I have to be able to do it in real time. A good way to get rid of those lines you saw there is there's auto gain control and auto white balance, which will affect the camera's internal, how the camera's looking at the image. So basically auto gain control will cause it to automatically change the brightness in the image and adjust the image quality, the dynamic range, essentially, whatever. It changes that so that the image will look better or look brighter and such. But if there's like sunlight coming in, the sunlight is slightly changing, so the auto gain keeps on fluctuating and it makes different columns look different. So you want to turn that off if you're taking a picture. You also want to turn auto gain off if you're tracking an object, because it will usually cause the object to change its color as it moves around because the shadows change on it. And then there's auto white balance, which will basically cause the color that the camera sees to shift to be gray. So if you were to hold a yellow ball in front of the camera, it'll change the color of yellow to look gray because it's trying to make the world look gray. The gray world approximation of the world usually makes sense for this camera track for most cameras, and that's how they do it. Usually they give a good color balance for everything pretty much. Like if you imagine, let's say the lighting in a room is, you have a regular incandescent light bulb and its lighting in the room is like tan or something. In order to make the lighting look white, the camera will auto white balance the image to change the lighting of the room to be more light looking. But that also means it'll change whatever color it sees in front of it. So you want to turn both auto gain and auto white balance off after you start tracking. But you want them to run for a little bit so that the camera can adjust to however the room looks or such. So once you have an image of something though, you can actually then start to track it. So you can go select object over here and select track selection or whatnot. And so the camera is going to, bound this blob of pixels around that image. And so you may see over there on the TV screen, the camera actually is in good lock. It usually is in color. I don't know why it's black and white over there. Let me see if I... No, it's in composite mode. Okay, forget it. Well, anyway, so over there, usually the blue, the massive pixels, that would usually be blue, and the bounding box would be red. I think there's something going on with this. I'm not sure if it likes composite video. Try it here. So. Okay. Oh, there we go. Okay, sweet. So the bounding box is the thing in the red around the image you see, and there's like a white dot there with the centroid. So the camera is going to give you, sorry, I didn't explain what those were. So the camera will give you a few measurements back about whatever color you want it to track. So it's giving you right there, the blue is basically all the pixels it sees that it's tracking, and the white is the centroid of that. That's like the center of mass of the whole object you're tracking, and then the bounding box surrounds everything. And so we can kind of pick that up and move it around. As you see, at 30 FPS, it's pretty smooth and whatnot. So this is not a great setup, though, by the way. Usually, to get the thing to work really well, you want to have contrived scenarios. A contrived scenario might be, the wall you have to shoot targets at. The camera will be looking at it. Well, the wall will not be moving. The lighting will be constant. Things will work really well in that situation. But something like this, I've kind of set it up haphazardly. I don't have a great angle of lighting coming on these things. The room is not necessarily bright right now because I turned the lights off. And also, the camera is looking straight down on these guys. There's a significant amount of shadow, so that's why it doesn't have exactly perfect tracking of an object. But I mean, in reality, you only need the centroid to be constant. You don't actually have to have the object be tracked perfectly. So as long as the centroid stays basically on the object, you still have tracking it pretty well. And so we can do that for whatever color you want, pretty much. Now, a few more things. So once you have this information, then what you're going to be able to do is plug these tracking values that the GUI automatically found back into your Arduino, and then you'll be able to track the thing without the computer attached at all. Question?
What's the range of this camera? Like how far?
Okay, so let's just well, the trick is it's kind of hard to really get a good, I'm not going to be able to give you a good demonstration of exact, perfect color tracking in a room like this without, putting a bit of effort into setting up the correct color bounds, but I can just show you with tracking random stuff and you can see how big I look. So, let's go over here. Let's just say track random things. Okay. So, do I have here? No. Let me try tracking my shirt. So this is a feature called track window, or just track whatever what's in front of it. Yeah, so there it goes. So that's the problem, is that you have to really constrain the lighting values to get a good tracking. So I'm just going to try a general wide selection of colors, and usually this will work pretty well. Bring this down to 7. Just going to do this for all channels. No, we don't do that because it would complicate how the serial output looks. But you can switch between different objects at different points in time if you like. So let's see if we can see the top. It looks like we have a huge amount of color or light being put in front of this. That's disturbing. Okay. So as you kind of see, I can get over here on the distance, and I can still make out my object. And so I'm still a pretty good amount of pixels on the screen and such. I'm just tracking a bunch of random things right now, so that's why it looks kind of stupid. But I mean, you can actually, bound your color more appropriately, and again, you're going to set your lighting up to be better than what it's currently right now, and have a better contrived scene or something like that, and it'll usually work a lot better. Again, it's kind of hard to pick your exact color I want to be, but let's see if I can. Yes?
So let's say you introduce something like tracking, how would you select that?
Yeah, so I'm going to get to that in a bit. It's a bit more complicated. For general object tracking of whatever color, you can do that easily. So, I mean, for the 10 feet we have to go, this is more than 10 feet, and clearly I'm a significant amount of pixels still in the image. So if you just get the color tracking bounds, or however I look right, then you'll be able to pick me out. Probably want to turn the lights back on, that would help also, but I have them off right now. Okay, so within this GUI, besides being able to pick the color you want to track, and you can also select the resolution that you want to get one of these pictures at, so you can dump them faster. You can send it to the SD card if you'd like also. So we can actually see what that's looking like in the GUI. If you don't have a TV, for example, you can see what colors it's looking at in the GUI, or the bounding boxes and where the centroid is. Just got to turn on this feature called line mode, which will send you 80 by 60 binary images. And so you can kind of see what's going on there. And also all the values of the bounding box and everything are all written right out here. Additionally, we have a few statistical things that this CMucam can bring over. So if you want to get a histogram of the current image channel, but the red, green, or blue, you can ask for a histogram. And so the histograms are going to be useful to you if you want to be able to more carefully pick out your color bounds, because you'll be able to see where the color distribution is. But also, the texture for whatever object you're looking at will change the histogram, so you can actually kind of identify different textures by looking at different histograms for different things and trying to match them. So you can actually get red, green, blue, etc. You can zoom in on this stuff too. You can drag this around. There's also some statistical stuff. If you want to get that mean, median, mode, and standard deviation of the color channels, that's built into. And you can get both of these things at the same time too, with switching mode enabled, which will allow you to get the tracking information and statistics information at the same time. Finally, for other modes, if you only want to get information about the color that's currently tracked, You can go to histogram tracking. So what's nice about that is that'll bound just the color that's being tracked. Can't really see it so much in this because I'm tracking a large range of stuff. But if I were to like pick out, well, I can just reset the tracking. There we go. So if we go back to this little guy over here, we can actually get the history. So if like, see what else it. Yeah. So while histogram tracking is on, this is actually just the color information about the object, about the colors that are currently being tracked, which is useful if you want to see whether or not the median of that, or the area of color is moving around and such. So you see the histogram looks different than if I were to turn that option off. Okay, well, that's just a bunch of random stuff in there. So, any questions before I continue? Okay, so a bunch of features in here. You can play with auto gain, auto white balance. You can flip the image, horizontally mirror it. You can go into black and white mode. If you just want to ignore all the colors and have a black and white scene, you can go to negative mode. You have a test mode built in, so you can see color bars of the image. Sorry, you can see color bars instead of an actual image. What that's useful for is if you're not confident that your algorithm works yet, you can just get a picture of color bars from the camera and then test out stuff with a static image. There's also YUV mode, which you can switch into, or I'll show you a bit of that. So in YUV mode, the images are going to look really different. So what's going to happen is when you put the camera in YUV mode, everything will work exactly the same as before when you're interfacing to it, except that all the colors will be from a different picture effectively. So what it'll do is it'll map the Y argument into the green channel, the V argument into the red channel, and the U argument into the blue channel. And so your images are going to look kind of like this now. You can see over here. It's kind of greenish, and all the colors tend to look really weird. You may have noticed that it looked like the red ball became orange and the orange ball became yellow. This is because YUV mode, the U and the V arguments tend to hover around a center point of their range, and they tend to change between, like, let's say the center point is 15, they'll go to like 0 or 31, but they aren't like the regular red and green, which, well, red, for example, which will go from 0 to 31 normally in a linear scale. The YUV kind of moves around the center. So you get weird colors. But you can still track everything just the same in this mode. And you get a bit better bounding and lock on the object pretty much. The lighting actually is basically separated from the hue. So what you can do in YUV mode is give a very relaxed bound with a Y argument and a very tight bound around your color, which is just the U and the V arguments. And so you have better tracking in general. So other things, for example, you can enable automatic panning and tilting. I'm not really sure if this is going to be super useful to you guys, but what it will allow you to do in general purpose. Camera will. Oh man, I think I drew the better. So it doesn't really respond. Oh yeah, okay. That's okay, well I was going to demonstrate the automatic panning and tilting, but I think I left the power plugged into this all night long. It seems to have drained out all the batteries. That sucks. Okay, well continuing on. A bunch of options in here for other stuff besides that, but it does have automatic panning and tilting, which you can enable so the camera will follow around automatically the object that you're looking at. So normally if I held up here, it would lock onto it and turn and such. Also, for other stuff, you can manually control the servos, you can change the brightness and contrast in the image, and one important feature is that you can turn on a noise filter to get rid of noise pixels. So often when you try to track some kind of object, you won't be able to really lock onto it perfectly, get the color bounding it perfectly, and so using the noise filter, you can kind of get rid of extra colors in an image. So the best way to demonstrate that is we just track a bunch of random things. And so there we go. Well, that wasn't perfectly. Let me hold this. got an object. All right, so now we're going to turn the noise filter on it. Okay, so you may have noticed how it starts getting all the, like, any noise pixels around the thing got went away pretty much. And if we turn that up, you see the image like being drawn, a bunch of lines being drawn on it. Essentially what the noise filter does is it looks for any, basically you can imagine in a row of pixels on the screen, it looks, whatever the noise filter value is, which let's say I set it at 14, it'll only track pixel rows that are longer than 14 pixels. So a pixel row is like a row of pixels that have, you know, a non-tracked pixel around it. And what that does is any untracked pixel, like little noise pixels in the image, pretty much disappear when you turn the speech filter. And there's also an inverted filter, so you can like track the opposite if you want, etc. Yeah, anyway, there's a lot of features in there. So the GUI will let you really touch all of that and pretty much anything else you want. And there's a little file system explorer here too. So if you want to like go on the SD card and figure out what pictures you saved to it, or etc., it has that ability. You can bring them over right to the PC. Any questions about the GUI? Anything else? Y'all are horrible on answers. Okay.
What the tracking tab?
What?
The tracking tab. We went to the options one before.
Yeah, the tracking tab was a visualization of all the data that the camera actually sends you, and it's the exact same data. Like this whole GUI implements the Arduino interface library, so every feature in this GUI you have access to inside of your Arduino. Okay.
So, for YUV mode, I noticed you made the red ball and the green ball, or the red ball and the orange ball look the same. Is it going to still track them very similar?
Well, see, the reason why that happens is because the U and the V arguments, I was trying to allude to this before, but I didn't explain it correctly. So, basically, if you imagine we have a red, right? Red's going to have this, you know, like, so just by the way, the images are in a RGB 565 format. So that means 5 bits for red, 6 bits for green, 5 bits for blue. So normally, like, red would go from 0 to 31. And when you put that in the image on the computer screen, if you see a value of 0, that's really dark. And a value of 31, that's really bright. So when you're in YUV mode, suddenly R is now the V argument. And the V argument likes to hover around 15, and then it'll usually, you know, if you go from if it changes from being no color to some color, it'll go to 31, or the opposite. So when it goes to 0, instead of actually coloring the object in a RGB mode picture, it just disappears. So that's the issue there. And that's why the image looks green also, is because the Y argument, the lighting in the scene, is mapped in green. So basically everything is shaded in green. We could have actually saved the images on the GUI at least in YUV mode format so they looked correct, so they wouldn't map exactly to what images the CMucam spits out. There's not enough time to do the color matrix transform to turn our YUV stuff into RGB mode for displaying purposes, but really wouldn't want that either. Yeah, it just looks different, but I mean, to the camera though, it doesn't care. There's a one-to-one mapping between the image and how the camera will track stuff. So it'll actually, while they look the same when they sit in the image, they'll track different and such. Did you get that? Yeah. Okay. All right. So, yep.
You said you can only track one color at a time. How quickly would I be able to, say, switch between tracking 3 different colors?
Yes, so if you want to switch between tracking 3 different colors, it only takes about 4 frames to do that. So I can actually modify the firmware to make it take like 1 frame, so you know, it's 30 FPS, it's only a few milliseconds to switch between. To actually make it track multiple colors easy too, in the CMucam4 also supports a feature called a tracking window, which you'll see right down here. So the window in which it tracks objects, you can control where that window is faced in its field of view. So if you don't want to track anything on the bottom half of the screen, you can set the tracking window just for the top half, and thus it won't see anything on the bottom, it won't even come into play. And so the tracking window actually affects where all the colors are sampled from, where the tracking calculations are performed. So basically changing that window, whatever is not in that window is ignored entirely. I forgot to mention two values that are kind of important to how the camera works. So there's something called the pixels and the confidence value in addition to that centroid and bounding box. So the pixels value will tell you like how big an object is in the image pretty much. It basically gives you the number of tracked pixels within the current virtual window, or the tracking window, that window I said that the camera is working on. That's normally 160 by 120, but you can change it to be smaller again. But the pixels argument, which it sends you back, will tell you basically how big an object is, essentially. There's also another argument, another value called the confidence, which is really useful. So the confidence is basically the area of the bounding box divided by the number of pixels tracked. And, sorry, the number of pixels tracked divided by the area of the bounding box. So, if you can imagine, well, I actually have a slide on this, so I'm just going to go over it. But, well, let me just say right now that the slides are going ahead. So, what will happen is the confidence value actually will be really high right now because the bounding box tightly bounds that little bit of color you see there. It won't be like really great though because there's still a bunch of black in that box. But if you can imagine we had two objects trapped and the bounding box surrounded both of them, then but the rest of the image is blank or something like that. You have a low confidence because there's like multiple objects. So basically we have a nice good firm block on something. The confidence will go way up and that'll basically tell you whether or not it's tracking random things or whether it's actually tracking a solid object.
I had like a painted picture frame on it, the color I was looking for. Would it have a really low confidence value since there's a big void of it?
Well, yeah. I mean, you usually want to try to bound that object to be in the size of. I mean, it's just
thinking about like the sliding targets.
Oh yeah, no. So this is a slotted and the camera's rotated to be the proper size. The bounding box can grow and shrink on the tracked pixels. So as long as the tracked pixels aren't like diagonal or something, where they're causing the bounding box to grow around them. If they're like this, then the bounding box are really pretty much perfectly encapsulated. Also, you have the ability to just look at the TV and see whatever the thing's seeing, so you can ignore that value if you want. You don't have to use it. But that's the CMucam GUI. And so we also have our Arduino interface library I said before. So what that's going to be useful for is actually communicating to this thing using your Arduino to interface with it and connect it and whatnot. And so the Arduino has all the same features as the GUI and do all the same thing, except on the Arduino you don't actually have memory, so you really can't bring a picture into your Arduino. I got tons of questions from that other people on my online forum that I run for this thing. You're not storing a 640 kilobyte image on 2 kilobytes. It's just not going to happen. I know, it's sad. Plus there's no screen on the Arduino, so you really can't get back. You can't print the image to a serial port also. It's not going to work. Just have to mention that stuff though. I've got questions about it. So the Arduino interface library is a nice file, C++ and C file, H file that I wrote. And you can just download these as the Arduino library. They all have, all the comments are in Doxygen, so I generated a nice Doxygen web page for the thing, which you can go to. Okay. Yeah, so anyway, here's the Arduino interface library main page, and so you can get the code from here too. I think it's there's a link for it. Yeah, you can get there right there. And this will basically tell you how to use the library and such, and how to initialize the camera and everything. The Arduino interface library you can actually port to whatever processor you plan to use. If you don't want to use Arduino, I wrote it to be portable, so you can really move it to anything else. All you can do is supply some basic serial primitives and timing primitives to the library, and it'll be fine. To connect it to your Arduino, what you want to do is you want to connect your Arduino to your CMucam4. For example, I have Arduino underneath this thing. You guys can see kind of right there. So you can just put this guy on top of the Arduino and it'll connect to it. In general, though, you want to use our Arduino Mega or something with more serial ports than a regular Arduino. The reason for this is that the CMucam is going to take up one serial port, and if that same serial port is your debug port, on your device, you suddenly don't have the ability to debug anymore. So with the regular Arduino, using CMucam is kind of a bad experience. But for Arduino Mega, it's really easy then because you have an extra serial port, so you can just put the camera off the side. And the way you connect that is you have the TX pin going to from the camera, going to the RX pin of the Arduino, and vice versa. You have to plug the serial in full duplex style. Okay. Also, if you try to just use a regular Arduino, there's going to be programming issues, as I said before, of like trying to program a camera being connected and a bunch of crazy stuff. I have a whole paragraph on how that works right over here. Just use a Mega, and you don't have to read any of that. Okay. Now, for initialization purposes, the CMucam really easy in the interface library. There's a begin function. You'll call it, and it connects to the CMucam4, and it makes everything start working. All the functions in the interface library all return negative numbers when an error happens, an actual error value. So if things not working, you can just print the error out, and it'll kind of tell you what's wrong. Usually it's like some kind of timeout error, which means that the camera is either not connected to your device or something like that. So if you get those errors, you just debug it yourself instead of asking me. Also, yeah, that's basically the only thing there. So packet types for the interface library. This is an important thing. So the way that you actually get data from the camera is you're going to get these things called packets from the camera. It's going to send you these serial packets. So the serial packet is going to be a struct, and there's going to be a function. Let's talk about how do you actually get them first. So there's a function called track color in the interface library, for example. So you call the track color function. You're going to basically give it a red bin, give it all your tracking parameters, just a bunch of colors that you're looking for. You can figure those out in the GUI. And you also probably going to want to play with the values the GUI selects so that you can handle the lighting a bit better. Because the GUI will pick a tight bound, so you want to maybe relax the colors a bit. Just have a larger bound so you can track the object with lighting changes on it or whatnot. And so you'll issue the track color command, and when you do that, the camera is going to go into this thing called stream mode and start sending you packets at 30 FPS of whatever color you're tracking. So the trick is you can't tell it a new setting and have it stay in stream mode at the same time because the serial link only allows you to have one direction kind of communications, how to do handshakes and such. So the interface library automatically handles kicking the camera out of stream mode if you execute any other function. But this also means that when you tell it to go into stream mode, you can't modulate the settings constantly at a higher frame rate. You have to stop it in its current tracking mode, select new settings, and tell it to track something else basically. Now while it's in stream mode, you can execute these things called get functions, basically. Like one of those functions will get you a type T data packet, which is a tracking data packet. So the track window command will send you a type T packet. Type T packet was this thing, so it's just a struct. And you'll execute, after you execute the track color function, you'll execute a get type T data packet function, and that will then return to you via struct. So you pass a pointer to the struct, it'll populate that struct with your tracking packet, and return you an error whether or not it got the packet or something bad happened. So the trick of how this works is you need to call, if you're in 30 FPS mode, tell it to check the color, and you want to get data packets back, you have to actually call that get type T data packet function at 30 FPS. Otherwise, you can imagine the packets are coming into the Arduino, they're taking up serial port space, but they aren't being removed. So what happens is your serial buffer will overflow, and then other random things will happen, and the system will get out of sync. Now, the get type T data packet function is blocking. So if you call it a loop, it'll basically cause your loop to run at 30 FPS, locked into the same frame rate of the camera. What this also means, though, is that you can't put delays in your loop. Like a lot of people I see look at the code and say it's not working because they put a 100 millisecond delay or something at the same time as calling this function in loop. And they obviously didn't read the main page where I mentioned how to do that. But yeah, so you don't want to put delays in your code in general when you're using this thing. When you're in a when you're in a locked loop like that. And so there's other types of packets. There's a packet for the histogram data, so you can get 1, 2, 64 bins of histogram data. 1 bin histogram isn't so useful, but I just threw it in there anyway for completeness. You can also get statistics data, which would be like the red mean, all your mean, median, mode, and standard deviation. And you can also get something called the type F packet for image data. So the type F packet, you may have noticed on the computer there was a blue image on the computer or whatever the CMucam4 is tracking, like the image that looks like what you saw on the TV. And so the camera actually will send you an 80 by 60 image of all the tracked pixels. So this is actually a 160 by 120 image. It has to downsample it in order to send it through the serial port at a fast enough rate. Yeah, the serial ports aren't fast, so you can't really send everything you want through there. So you get, but anyway, it'll send you an 80 by 60 image of whatever it's tracking. And so you can actually do post-processing on that image to do a bit more interesting stuff. In fact, that's how we're going to do types of applications you need for this class. The trick to notice is that you are getting an 80 by 60 image at 30 FPS, and the Arduino is not a computer. So you should really be careful about how much processing power you want to throw at processing all the pixels in the image. Maybe you get an Arduino do, since it's 4 times faster. I don't know, but when I was writing the interface library, at least, the Mega was able to receive the 80 by 60 image, but it's kind of stressed out by doing that. So just be careful about how you code stuff. Don't put in delays and don't start executing things that take forever, like lots of floating point functions. It's a really bad idea. One thing, the Arduino Uno or non-Mega Arduinos can't actually handle an 80 by 60 image. They're stack overflows. So if you do try to get these image data packets of Arduino regular, it's just going to stop working, like, randomly. Can't really do anything about that. It's just the limitation of the Arduino only having 2 kilobytes of RAM. So the Mega has 8. That's going to help out allowing you to actually store some of these images. And so there's also some functions in the interface library that allow you to get pixels inside this, inside one of these images. And I have a function macro so that you can embed that into your code for a really fast, tight loop, if you'd like. Anyway, that's basically the packets that they will send to you. So it's going to send you those packets. Also, there's one more thing. There's something called poll mode, where in poll mode, the CMucam4, instead of sending you like continuous packets at 30 FPS, they'll just send you one and then stop. And so in poll mode, you can basically pull the camera for the current, whatever it's tracking or whatever it's looking at, or you can pull it for images, or et cetera. You can pull it for whatever you want. And you aren't then bound to that contract of being able to receive the images at 30 FPS. The trick though is in poll mode, the frame rate's not going to be at 30 FPS, you're only going to be able to get about 10 FPS or so. But that should be good for most forms of motion. I mean, it's pretty fast. It's not as fast as you can go, but it's not honestly that horrible. Anyway, moving on. So you should all, there's actually a manual, like a 56-page manual also for this thing. If you have any questions about what commands do and you're still looking for a bit more information, check the manual. Anyway, okay, so you already covered this object tracking. So you can see the confidence value might change when you have different stuff in the image. Like bounding box is kind of looking around this object, so it's a high confidence. This is a low confidence situation because the centroid is in the center, so the average of these two objects that is the center. But obviously that's not what you want. So that's why the confidence is lower, because the bounding box is very big for how much color you have in there. Now, we're going to cover 2 things. Examples of how to do, so like if you're doing the robot that's going to be throwing the frisbees, you're probably just going to want to use the regular object tracking feature, which is the track color function. So your object's going to be whatever colored label you have that the camera's looking at. And so once you have it tracking that, then it'll give you some X and Y position for the centroid that you can then use with some bit of kinematics to look up exactly where you should aim your robot's frisbee shooter in order to get that into a hole or whatever. And so if those holes are moving also, or I'm not sure what make a moving hole, but I guess maybe it's a target or something, I don't know. But if those are moving also, you can get into the same thing. So another thing, for like a shingling robot or a general purpose line tracking, when you have one of those binary images, you can do post-processing on. So this example says, let's take a bunch of horizontal stripes from one of those binary images the CMucam sends us after we've already tracking colored line. And then let's compute the centroid of all those horizontal stripes. It's really easy calculation. You just loop through one row of pixels and add up all the X positions and then divide it by the length of the row. That'll give you basically the center of mass of all those rows, essentially. And what we have after that is a bunch of dots that effectively tell us where the line is in time. And so you can put those lines, you can space them at different intervals. You don't have them being equal. You can have one or many or more or whatever. You can change it up. And using whatever algorithm you want, you're making the line tracking robot, you can then track a line like that. Also, you could rotate that picture and have the lines maybe going vertical or horizontal or any other form. Maybe the line isn't in front of you, maybe it's horizontal like this, like a plumbing line where you're supposed to lay tiles. And so you could also figure out where the line is using this approach. More complex things, maybe you might want to do a linear regression on that stuff. So you have these points in an image. You could do a linear regression and figure out what the equation of the line is. If you're trying to line up a robot to a line on the ground or such, maybe you want to try to make it so that that line is flat or doesn't have any slope on it. And that might mean that the camera is lined up perfectly to it. Maybe you can adjust the Y argument of that line to position your camera over top of it or something like that. So there's all types of stuff you can do. You just have to be a bit creative with it. CMucam4 is a toolbox of features. It's up to you to really figure out how you're going to use it, given its feature set, to perform a particular application. Anyway, that's about everything I have. Questions?
With the horizontal tracking, that example, you mentioned post-processing. Does that mean it's done on the microcontroller?
Yeah. So, I mean, the CMucam sends you that binary image, 80 by 60 pixels. If you're in the 30 FPS mode, you don't really have a lot of time to work on it, but if you do poll mode, you have all the time in the world to do whatever processing you want on it.
So I don't, you may not have answered this. Have you talked more with Dr. Golan about how many are going to the class and what the price range is going to be for budgets?
So I have like 6. Now, how many teams are there? Forget. 14? 13 teams. Okay, so if I have 6. What? No, I just meant, well, yeah, tracking the line, like the shingler, because there's going to be plumbing lines. And I think, I'm not sure how it is. I know it's going to be horizontal plumbing lines. Are there going to be vertical ones, though? Because if it's not vertical ones, I don't know how we're going to place the tiles, like, aligned straight other than just, like, hard coding into positions, but that's horrible. So if you imagine if you have vertical and horizontal lines, then you can just, like, flip in between looking at, doing a linear regression for, like, vertical points and horizontal points, and you can figure out, like, okay, am I placing this tile correctly? Do I need to rotate my robot or whatnot? As for pricing, though, I mean, they're $99 on SparkFun. You can buy them. I have 6, and there's 14 teams. You can get that reduced a bit, so maybe $50. I don't know. I mean, they kind of solve a lot of problems for you. If you want to figure out how to aim at the targets using Wiimote, I guess you can do that, which is a bit more hacking. I don't know, this is kind of like so the purpose of the CMucam4 is to be a nice, simply use color tracking system for someone who hasn't, worked with robotics or electronics or anything like that. Like most people, they'll want to, you don't want to stay on their microcontroller platform of choice and not really branch beyond that. So they learn how to program Arduino. They want to do everything with Arduino. They don't have to go to a computer, figure out how to do vision processing on a computer, and then send data back to the Arduino, and they make a GUI. It's all those other steps where it just gets messy. And so this little system will kind of make that a bit easier for you, so you don't have to worry about all these things. You can do color tracking with other platforms, like a webcam and a Raspberry Pi. It'll cost you less up front, but you're probably going to spend, unless you're really good. So if you're really good, it's fine then, but I mean, If you don't know what you're doing, it's probably going to waste a whole bunch of your time, and that may be money to you. Maybe not, I don't know. My general view, though, time is money, so the less time I can spend messing around with things, the better. And so this will kind of make that a bit easier for you. Because the same problems of color tracking, we'll tackle them with a webcam, except you don't have all the features you can with CMucam4, like auto gain and auto white balance. Some cameras you can, some cameras you can't. Depends on how much money you spent on the camera, if it has that feature actually exposed. So you basically find yourself in the same position either way. You just got to choose carefully. Again, if you know what you're doing, it's not an issue. But if you don't, then it's a lot more education than you go through. Anything else? All right, thank you guys.